Welcome, ladies and gentlemen. We're going to run through the study guide now. I'm going to work these things out for you. Hopefully you will be able to keep up with me, and of course you can always stop the video and go back and go over things as we go along. So I'm going to just work these out. We'll see what we can do with them, and we'll go from there. Alright, so anyway, first type of problem, these are in no particular order. I'm not doing it in any order. If you look at these the items there in the middle, you can see the different things that we're going to be looking at in terms of the test. So what we'll look at now is just we'll go in order on the study guide. Now the answers are all there, but let's see how we got them. And as we move along this thing, you'll see how we're going to do with that. So if we take a look at the various things that are going on here, we can see in this first type of a problem that type of a problem is a percent composition problem. They give you the formula for beryl, which is a beryllium aluminum sulfate. So there's 4 different kinds of atoms there, and what they want to know is just the beryllium. We could do every element, but in this case what we're going to do is look up the molar mass of each of the elements. And by the way, before I get into this too heavily, it's going to be a series of videos since this is going to be a lot of information on here. So if we look up beryllium's molar mass, I'm going to do everything on these to the nearest tenth. So these are going to be 9.0 grams per mole. There's 3 beryllium atoms in there, so that's a grand total of 27. Aluminum, it is 27, and there's 2 of those, so that's going to be 54. The sulfur is, that's silicon. The silicon's molar mass is 28.1. And if you'll look at that there's 6 times 1, so there's 6 of those. And 28.1 times 6 is going to be something like 168.6. Then there's 18 oxygens. Oops, let's change this around so we keep this the same order. Molar mass 16, and there's 18 of those in there. So 16 times 18 is 288 grams per mole. Now these are all grams per mole. So when we add up and we get a molar mass, that will always be in grams per mole. So in this case, if we add all those up, 288 plus the 168.6 plus the 54 plus the 27, that looks like that's going to be somewhere in the ballpark of 537.6. So to get each one of the percents, you would take each total, so in this case 27 divided by 537.6, then take that times 100. You would do that with each of the other ones, and we'll just do an oxygen as well. We'll do 288 over 537.6 times 100 with a percent sign. But our target question was what's the percent of beryllium in here. So if we take 27 divided by that total and we multiply by 100, we get 5.02%. Now I only went to 3 sig figs. I didn't get as crazy as they did. And if we did the oxygen down there, the 288 divided by the 537.6, looks like that would be about 53.6%. So that's our first kind of problem that deals with percents. The second kind would be the type that deals with how many grams of beryllium would be in a crystal of beryl that weighed 536.3 grams. So we're going to, now this wouldn't always be the way it would be on a problem, but we've already worked that percentage up there. So if we take the percentage as a decimal, so we're going to redivide that by 100, and in this case then I'm going to say, well, that's going to be 0.0502 is what we had, times the size of the sample, 536.3, then that should give us the answer. So we'll do 0.0502 times 536.3, And it looks like we get about 26.9 grams. Not quite sure how they got 0.8. What is the percent mass of both elements in a ruby? Ruby is aluminum oxide. Aluminum oxide's formula, Al2O3. This was a +3. This was a -2. Cross the charges. So we have 2 aluminums. We have 3 oxygens. We'll take that times 16. We'll take this times 27. That's 54. This is 48. So the total is 102. If I take 54 over 102, 48 over 102, multiply by 100 with a percent sign, we should get those 2%. So we'll take 54 divided by 102. I get 52.9%, and then that would be 47.1%. That's to the nearest tenths. What's the density of the following gases? We found out that density equaled molar mass. Let me get my pencil back here. Molar mass divided by molar volume, we said. So the molar mass, now you can only do this for gases. The density of any gas is at STP. This should say at STP. Is the molar mass divided by the molar volume. Because if you remember, density is mass divided by volume. So if we're at STP, the molar mass divided by the molar volume. So the molar mass of oxygen is O2. It's 32 grams per mole. We're going to divide that by the molar volume, which is always 22.4 liters per mole. So 32 over 22.4. I'm going to assume is 1.43. It's 1.43, and the unit's going to be grams per liter because the moles will cancel. N2O, we're going to add up 14 and 14 and 16. So in that case, 14 for 28 and 16 is 44 grams per mole over 22.4 liters per mole. So 44 divided by 22.4, looks like that one's about 1.96 grams per liter. Argon's a monatomic gas. Argon is 39.9, so 39.9 grams per mole over 22.4 liters per mole. 39.9 divided by 22.4 is 1.78 grams per liter. So I don't agree with the 9 there on that one. Okay, so there we go. We could manipulate the density equation. We could say the density of a gas is 0.714 grams per liter. What's its molar mass? Additionally, is this gas oxygen, hydrogen, sulfur dioxide, or methane? So in this case, we know that density equals mass divided by volume. So to get molar mass, we would take the density times the volume to get the molar mass. In this case, molar mass, but this would be molar volume. So we know the density is 0.714 grams per liter. We'll take that times 22.4 liters per mole. Liters cancel. We have grams per mole, which is molar mass. So 0.714 times 22.4 is 15.99. So if we ran out to the nearest tenth, 16 grams per mole. So now you have to figure out which gas it would be. Oxygen is O2, hydrogen is H2, sulfur dioxide SO2, methane is CH4. So the molar mass of this is 32, 16 and 16. Molar mass of this is 1 and 1 is 2. Molar mass of this is 32 and another 32, that's 64. This is 12, 1, 1, 1, 1, that's 16. 16 matches 16, so this must have been methane. Okay, so let's look at a couple definitions real quickly. I'm not gonna write them down. I'm just gonna read them to you, all these, and you can write them down if you like. If you don't want to, that's fine too. Gram molar mass is just another way to say the molar mass. Just mark out the gram part. Molar volume is always 22.4 liters per mole at STP. Avogadro's number, 6.02 times 10 to the 23rd. A mole, the mole is the number of particles that are in exactly 12 grams of carbon-12 isotope, which is 6.02 times 10 to the 23rd particles. Molar mass, how heavy a mole of a substance is. Molarity, moles divided by volume. Solute, the material that gets dissolved in a solution. Solvent, the material that does the dissolving in a solution. Solution is a homogeneous mixture. It looks like one thing. Representative particle, the different types are what? Atom, molecule, formula unit, diatomic molecule. So those would be all those. Now the biggies, the maths. What's the mass of 0.873 moles of potassium thiocyanate? If we look at our mole map, in that case, I don't have a mole map handy, but if we had a mole map handy, we could look at that. And what I'm going to do is stop this video. I'll pick these back up, and we'll be able to look at a mole map as we do that. So check out the next video and let me know how you like it.